Here's an example in which we are starting with x equals 3 tangent of a, and we're supposed to rewrite this expression in terms of sines and cosines. Okay, so how do we go about doing it? Well, let's start by grabbing 3 tangent of a and plug it in right there for x and right there for x, right? And so, oops. What do we get? Well, we get 3 tangent of a. Oh, I was going to square. It's not square. Just 3 tangent of a on the top. On the bottom, though, we get 3 tangent of a squared plus 9, all in a square root. Right? Is that making sense? I just plugged in the x right there, and the x is 3 tan a. Okay. Now, what becomes of this? Well, on the top, 3 tangent of a. On the bottom, let me do our big square root here. This guy's squared. You square the 3 and square the tangent, don't you? 3 squared, you know, is 9. Tangent squared of a plus 9, like that. Like good so far? Okay. What are we going to do? Well, let's bring it down here. And this is where things get a little tricky. I would suggest, see how these both have a 9? I would factor it out. Do you know what I mean by that? 3 tangent of a all over. That's going to become, in the denominator down there, it's going to become 9 parenthesis tangent squared of a plus 1. Do you see what I just did there? That's called factoring. That's just distributing backwards, reverse distributing, right? Because that 9 could multiply back in and hit both those and go back to 9 tangent squared, and 9 times 1 would be 9, right? That it could go right back in, couldn't it? Okay, so that's called factoring. It's just reverse distributing, just undistributing if you want. Okay, so what? Great, I see it. Okay, well, here's a trick. What'll really help you is recognizing this guy. He's an important player that comes up a lot. When you see tangent squared plus 1, let's go back here to our formula sheet. You're going to have this formula sheet, right? Tangent squared plus 1, there it is. Do you see it right there? 1 plus the tangent squared, that's secant squared. Whenever you see 1 plus tangent squared, it's secant squared. So go, oh, these are all called Pythagorean identities. They are very similar, involving sine squared or cosine squared or secant squared or tangent squared and a 1. So 1 plus tangent squared is secant squared. So 1 plus tangent squared, this right here is secant squared. This whole thing is secant squared. So that leads us to this point now. We have 3 tangent of a over the square root of 9 times tangent squared plus 1, that's secant squared, right? I just replaced all that with secant squared. Okay, great, got it. So now what? Well, now, bring it down here. We're getting closer. Now, let's keep the top the same, I think. So the top is still just 3 tangent a. And the bottom, we're going to square root everything. You're going to square root the 9, that's just 3. And square root the secant squared, it just cancels that out. And we just get secant. Did that make sense there? Right? You know, when you square root a 9, it's 3. And when you square root secant squared or anything squared, it just gets rid of the square, right? And there's no more root. The root is gone. You see that? No more root. Why? Because the root canceled the squared, right? If you square root 9, it's just 3, no more root. Or if you square root x squared, it's just x, no more root, right? The root and the square cancel each other out, and you just have regular x. The root cancels out the 9, you just have regular 3. You do the root, in other words, and the root's gone. So, the root's gone. So, where does that leave us? Leaves us almost done. We're close. Now, we have to do what they told us in the beginning. Sines and cosines. Write these in terms of sines and cosines. We have a tangent on the top here and a secant on the bottom. Sines and cosines, Let's look to our formula sheet. Tangent is sine over cosine. Secant is 1 over cosine. So let's go do that. So we have 3 tangent, that's 3 sine of A over cosine of A. Right, the tangent becomes sine over cosine. And the bottom, secant, is 1 over cosine. So we good to there? Now, do you know what to do at this point? Let me write a note. I've written it a few times. Let's see if it makes sense for you. When we have fractions over fractions. Whoops, didn't mean to bump that. When we have fractions over fractions, what do we do about that? You multiply all the terms, top and bottom, by the LCD over 1, and the LCD, well, let me just put it there, LCD is 1 of each type of item under the small bars. One is, so the LCD is 1 of each type of item under the small bars. So we go up there and we go, all right, what are the small bars? You know what I mean? Like this is the big, I did the wrong thing there. You know what I mean? This is the big bar. We're not talking about that. We're talking about this small bar, what's under it? Cosine. And that small bar, what's under it? Same thing. So you just take one of them, right? One of each type of item that's under the small bar. That's the LCD, and you multiply by that over 1 to all the terms top and bottom. So let's do it. I'm going to multiply by cosine of A over 1 top and cosine of A over 1 bottom. So just like that, we don't do it. The threes are not separate terms. Why not? There's no plus or minus between them. If there was a plus or minus between the 3 and the fractions they're next to, then they would be separate terms, and they would also get their own cosine of A over 1, but they're not. They're all just one term. So we just put the 1 cosine on the top and the 1 on the bottom. See how I'm doing the same thing, top and bottom, so I'm not really changing the fraction. I'm multiplying by LCD over 1, and the LCD is just what's under the small bar. That over 1, top and bottom, so I'm not changing the fraction. When you do the same thing top and bottom, the fraction doesn't change. It just looks different. What happens? These guys cancel. These guys cancel. What are we left with? 3 sine of A over 3. Oh, just 3. Kept looking for more. 3 times 1 if you want. The 3's cancel, of course. There's no glue here. There's no pluses or minuses. So this is not shopping at Costco, as I always say. There's no glued together items. This is shopping at Save Mart. You can buy just one. It's fine. We can cancel just the 1, 3 on the top, leaving the sign. And so what are we left with? Sine of A over 1, which is just sine of A. The 1 on the bottom doesn't do anything, right? So all of that work, it just boils down, it doesn't bear, it boils down to just be sine of A. We plugged in and simplified all the way to just sine of A.